Welcome to the Deep Dive. Today we're tackling, well, maybe one of the biggest questions out there. Have we finally hit a ceiling on how long humans can live?
It really is a huge question, and it's sort of the paradox of all our medical success, isn't it?
How so?
Well, we've done an incredible job extending average life expectancy over the last 100 years or so. Think public health, sanitation, vaccines, brilliant work.
Right, fewer people dying young.
Exactly. But let's say the ultimate prize, really radical longevity, living well past 100, that seems kind of stuck.
Okay, so that brings us to the core of today's deep dive. There's a major new study just out in Nature Aging this October, and it really throws down the gauntlet. It does. The headline finding, essentially, is that these big leaps in life extension, the kind that gets people routinely living to 120, 130, they're saying that's implausible in this century.
Implausible. That sounds pretty definitive, almost pessimistic. It can sound that way, but it reflects a crucial shift in thinking, I believe. What we've been amazing at is stopping people from dying young, tackling infectious diseases, infant mortality, huge wins.
Okay.
But that very success means more people are reaching old age. And that brings us face to face with, well, the fundamental process of aging itself and all the diseases that come with it.
So the idea is our current medical toolkit is great for, say, fighting off an infection and acute illness.
Absolutely.
But it's just not equipped to slow down the underlying process of getting old.
That's the argument in a nutshell. The researchers talk about this idea of a glass mortality floor.
A glass floor. Meaning we can see through it, but we can't break it.
Sort of. It's like a ceiling on the maximum lifespan, maybe somewhere around 115 or 120 currently. And they argue we can't just smash through it by improving existing healthcare or finding cures for individual diseases like cancer or heart disease.
We'd need something more fundamental.
Exactly, a biological breakthrough that tackles aging itself. But it's important to add, even the authors of that paper said these limits are not brick walls for longevity.
Okay, so not impossible, just really hard.
Right. It signals that the methods that got us here, extending the average lifespan, have probably done most of what they can do for the maximum lifespan.
Okay, let's dig into the data that led them there. They looked at figures from 1990 to 2019 across countries where people live the longest. What did that historical data show?
Well, the really key thing, the distinction, is that while the average age people live to kept creeping up, more people reaching their late 80s, early 90s,
Right.
the maximum lifespan, the record age anyone lives to, that didn't really budge much at all. And maybe even more concerning, the pace of that increase in the average lifespan has slowed right down recently.
And we see that really clearly here in the UK, don't we?
We do. The latest figures, 2021 to 2023 for England, show average life expectancy has actually dipped back to levels we saw around 2010.
What are the numbers again?
It's about 79 years for males, 83 for females. That slowdown, that dip, it forces a really important question.
Which is?
Is the slowdown because we're hitting some fundamental biological limit? Or is it something else? Something about society?
And this is where the debate really heats up, I imagine.
Oh, definitely. You've got researchers, Jan Wies is one name often mentioned, who look at this data and say, yep, this suggests some kind of biological ceiling. Our basic design just wasn't built for much more.
The hardware limit, essentially.
Kind of. But then you look at those recent UK figures that dip.
And others point the finger squarely at policy.
Exactly. People like Jerry McCartney argue this isn't biology, it's the result of policy choices. Things like cuts to social benefits, strains on healthcare services, rising poverty, economic hardship.
So they're saying if we invested more, reverse those cuts, we'd see life expectancy start climbing steadily again.
That's the argument. It creates this real tension. Is the limit in our genes, or is it in our social and political decisions?
And then you have the third camp.
Yes, the radical optimists. People like Laura Dimming from Age One. They look at the incredible pace of progress in basic biology, genetics, cell science.
And they say,
look, with enough investment, enough ambition, there's potentially no upper bound at all to how long humans could live.
wow, okay, that's a bold claim. But it brings us back to the fundamental biology. Why would evolution build in a limit? We can maintain machines, buildings for ages. Why does the body seem to break down after 80 or 90 years?
Yeah, it seems counterintuitive, doesn't it? But you have to remember evolution's prime directive.
Survival of the fittest.
Well, yes, but fittest for what? Evolution doesn't really care how long you live after you've passed on your genes. It's about reproductive success.
Right. Survival long enough to reproduce.
Yeah.
Not survival of the oldest.
Precisely. So for most organisms, especially when resources are plentiful, the winning strategy is often grow fast, get strong, reproduce early and often.
Live fast, die youngish.
Basically, yeah, pour all your energy into growth and reproduction, even if that means neglecting long-term maintenance and repair. That fast-track approach inevitably leads to faster wear and tear. That's the trade-off. That's aging from an evolutionary standpoint.
Okay, but here's where it gets interesting for longevity science, right?
Yeah.
Because the body isn't always on that fast track. It can switch priorities.
Exactly. This is where the caloric restriction evidence comes in. It's fascinating.
Tell us about that.
So imagine an organism in the wild, and suddenly food becomes scarce. A famine hits. Does it just keep trying to grow and reproduce and then die quickly?
Probably not the best strategy.
Right. Instead, many organisms have this incredible backup plan. They shift resources away from growth and reproduction and pour them into cellular maintenance and repair. They essentially hunker down, slow down aging to try and outlast the famine.
Putting the brakes on aging to survive a threat.
That's the idea. And we see this consistently in the lab. Take simple organisms, worms, flies, even mice. If you restrict their calorie intake by, say, 20 or 30%,
They live longer.
significantly longer. But crucially, it's not just about lifespan. They also delay the onset of age-related diseases, cancer, cardiovascular problems, things like that.
Which tells us aging isn't just random decay. It's a process that can be, well, manipulated.
Yes. It suggests there are dials we can potentially turn. Now, for humans, obviously we can't do decades-long starvation studies. It's unethical and impractical.
Of course.
But clinical trials are underway looking at things like intermittent fasting or time-restricted eating. The hope is we can kind of trick the body into activating some of those protective maintenance pathways without chronic starvation.
And this links directly to what many see as the core problem in aging, right? Metabolism.
Absolutely. Think
do
about it. Age is the single biggest risk factor for almost every major chronic disease. Alzheimer's, cancer, diabetes, heart disease.
They all ramp up dramatically as we get older.
Exactly. Which strongly suggests there's an underlying mechanism. And a lot of evidence points towards metabolic dysfunction and how our bodies process fuel and energy.
Can you explain that a bit more?
Sure. Think about metabolic flexibility. When we're young, our bodies are generally pretty good at switching between burning sugar for quick energy and burning fat for sustained energy.
Yeah.
Efficient.
Like a hybrid car, switching smoothly between gas and electric.
Perfect analogy. But as we age, we seem to lose that flexibility. Our systems get, well, gummed up. We might become insulin resistant. We start storing fat in places it shouldn't be, like the liver or around organs.
The engine stalls out.
Pretty much. It contributes to inflammation, cellular damage, the whole cascade of problems we call aging. So a huge part of geroscience is trying to figure out why our metabolic signaling goes awry over time.
Okay. So we have evolution maybe giving us a limited warranty and maybe policy sometimes holding back average lifespan. Geroscience then is the attempt to rewrite the warranty, maybe even void it entirely. How are scientists approaching this? It seems like there are two main strategies.
That's a good way to put it. Yes, broadly speaking, there are two paths. Path one is what you might call the public health approach. This is about improving the median lifespan, studying people who age exceptionally well, centenarians, looking at their genetics, their lifestyle, diet, social connections.
And applying those lessons to help more of us reach the current sort of healthy upper limit, maybe 90 or so.
Exactly. Helping more people live healthier for longer within the current known limits. That's incredibly important work, vital for public health right now.
And then there's path two. The moonshot.
The moonshot, yeah. Oh, this is the high-risk, high-reward stuff, trying to actually change the fundamental biology of aging to push past that current maximum limit.
Breaking the ceiling.
That's the ambition. This involves things like cellular rejuvenation, trying to turn back the clock on our cells, making old cells behave like young cells again.
Like reprogramming them?
Kind of. Using strategies to revert adult cells towards a more youthful, stem cell-like state. That February 2024 study in mice you mentioned earlier, that fits here.
The gene therapy one.
Right, where they reported increasing the average lifespan in those mice by, what was it, 109%?
An incredible number. 109%. But mice aren't humans. How big a leap is it?
It's a massive leap, and that's the crucial context. Mice live maybe 2 or 3 years. Their biology is much simpler in many ways. Getting that result shows a biological mechanism might work. It demonstrates potential.
But it doesn't mean we can just inject ourselves and live to 150 next year.
Absolutely not. Translating that to humans safely and effectively could take decades if it's possible at all. It's proof of concept, not a ready-made cure.
Okay, let's talk about an intervention that is being tested in humans, though. Rapamycin. There was a systematic review recently.
Ah, rapamycin. Yes, it's one of the most studied potential gerotherapeutics. It's really interesting because it targets a key pathway involved in that nutrient sensing and aging process we discussed.
The MPR pathway.
Exactly. Think of MTR as like a master switch or sensor in the cell. When nutrients are abundant, MTR is active, telling the cell, grow, divide, consume resources.
Driving that live fast strategy.
Right. But rapamycin inhibits MTOR. It basically tricks the cell into thinking resources are scarce even when they're not.
Like mimicking caloric restriction.
That's the idea. It pushes the cell towards maintenance, repair, stress resistance, those protective states.
And what did the human studies show? The review.
It showed some positive signals, improvements in certain parameters related to aging, particularly in the immune system, cardiovascular health, and skin health.
But not a slam dunk.
No, definitely not. The review also noted it didn't seem to affect other systems. Aging is complex. Hitting one pathway doesn't fix everything. Plus, there are potential side effects.
And there's a big challenge just getting these kinds of drugs approved, right?
A huge one. Regulators like the FDA or MHRA approve drugs to treat specific diseases. How do you get a drug approved to treat aging itself, especially for someone who is currently healthy?
You'd have to convince them aging is a treatable condition.
Precisely. That requires a whole paradigm shift in medicine and regulation. It's a major hurdle for the field.
And while the careful science grinds forward, the commercial world hasn't waited. We're seeing this explosion of longevity clinics. What's going on there?
Oh boy, yeah, it's kind of the Wild West right now.
Unregulated.
Largely, yes. You have everything from high-end clinics offering sophisticated diagnostics, genetic testing, personalized nutrition plans, some potentially based on decent science,
Okay.
all the way down to places offering unproven, sometimes dangerous therapies like certain stem cell treatments, often offshore. There are no set standards, no real oversight.
Presumably it's not cheap.
Not at all. This sector currently caters almost exclusively to the wealthy. It raises huge equity concerns right away.
And you also see a lot of hype online, right? Health influencers making big claims.
Yes, and that's a real worry. You see people making these bold statements, as you say, often based on extrapolating wildly from, say, a small study in worms, or maybe just a correlation that isn't causal.
Like the ice bath trend, maybe? Or extreme heat exposure.
Things like that. They might have some short-term physiological effects, but they get presented as proven ways to radically extend life, often with very little solid evidence. Science, especially geroscience, has to proceed slowly and carefully. Biology is complex. We can't speak in absolutisms.
That caution feels really important, especially when we pivot to what might be the more pressing issue for most people right now.
Yeah.
Not just living longer, but living healthier for longer. Expanding health span.
Exactly. This, I think, is the most urgent and practical mission. What good is living to 110 if the last 30 years are spent in ill health, with severe disability?
And the data on this is quite sobering, isn't it?
It really is. The average number of years people live without a disability, what we call healthy life expectancy, is typically about 20 years shorter than total life expectancy.
20 years. That's a huge gap.
It's enormous. Think about the personal cost, the burden on families, the strain on healthcare systems like the NHS, the economic impact.
It's massive.
Absolutely. So if geroscience could translate its findings not just into longer life, but into closing that 20-year gap, extending healthy lifespan, the benefits would be transformational.
People could stay active, stay in the workforce if they choose, contribute longer.
It would ease so many societal pressures, reduce healthcare costs, maybe alleviate some of the financial burden often associated with aging populations.
But we can't talk about improving health span without acknowledging the massive inequalities that exist right now.
You absolutely cannot. The disparities are shocking. In England, for example, life expectancy in the most deprived areas is over 10 years shorter for men and over 7 years shorter for women compared to the least deprived areas.
So social policy, or the lack of it, is already drastically shortening lives and health spans for huge numbers of people.
It effectively mimics accelerated aging for the disadvantaged. It underscores that any gains from fancy geroscience interventions will mean little if we don't address these fundamental social determinants of health. Otherwise, the benefits just flow to the privileged few.
So adapting society for longer, healthier lives isn't just about finding a pill. It's about building better communities.
It has to be. It requires investment in what you might call senior-friendly infrastructure, robust social care, accessible recreation, affordable and suitable housing, good public transport.
things that maintain independence and connection.
Yes, and proactively addressing things that often isolate older people, like hearing loss or vision impairment. These are the societal moonshots, perhaps just as important as the biological ones.
And related to that, we probably need to challenge the constant narrative of the aging crisis, don't we?
Oh, definitely. That rhetoric is far too simplistic and often counterproductive. An aging population isn't inherently a crisis, it's also a massive resource.
How so?
Older adults contribute hugely. Many stay in the workforce, they are vital volunteers, they provide enormous amounts of family care, especially childcare. Viewing longer lives purely as a burden is completely missing the picture. Healthy aging makes society more resilient, not less.
Okay, so let's try and synthesize this deep dive. We've covered a lot of ground.
We have. I think the consensus, if there is one, is that while there might be biological limits to lifespan, they probably aren't impenetrable brick walls, just very high ones.
And breaking through them will require these ambitious biological moonshots that geroscience approach.
Yes. But that's likely a long-term prospect. In the short to medium term, the biggest, fairest impact comes from integrating what we already know.
Combining biology, social science, public health, nutrition.
Exactly. Focusing squarely on increasing health span for everyone, making those potential 80, 90, maybe even 100 years as healthy and fulfilling as possible. That's the immediate, achievable mission.
Improving quality of life within our current potential.
That has to be the priority for policy and public health right now.
Okay. But as we wrap up, let's leave our listeners with that bigger, more provocative question that underlies the whole extreme longevity ambition. Ethicist John Davis raised it.
Ah, yes, the planetary limits question.
Right. If that second longevity revolution does succeed, if we figure out how to push maximum lifespan radically higher, 150, 200 years, who knows what happens then?
Davis specifically worried about, quote, really spectacular increases in population on a planet that I personally feel is already overloaded.
So if our ambition to conquer biological limits succeeds, do we just run headfirst into ecological ones? Can the planet actually sustain billions of people living for centuries?
It's a profound ethical and practical question, isn't it? What new limits emerge when we overcome the old ones? Something for you to definitely think about as you hear more about the quest for longer life.